So we're going to continue on with question 9. And now we're looking at part B. So what we want to do is find the exact coordinates of the point P. Now, reading a bit of the information given just above that, the points P and Q represent points that are furthest west and furthest east of the origin O in figure 4. So that's point P here and point Q here. So that's a point itself. And then we have these vertical dashed lines which tell us that the gradient at each point is actually going to be infinite. So dy over dx, and we have that expression here, at P and Q will actually be infinite. So what that means is the denominator of this differential expression must equal 0 for us to have infinite gradients at P and Q. So at P and Q, if dy over dx goes to infinity and dy over dx is equal to y minus x over 3y minus x, then for dy over dx to tend to infinity, the denominator of this expression must be 0. So that means 3y minus x must equal 0. So now we have this expression, this linear expression in terms of y and x. And of course, we have the original equation, the curve. So what we can do is we can substitute in 3y minus x equals 0, or we can write it as 3y equals x. We can substitute this into our curve equation. So I'll write it all here on the left. So substituting, so I'll write this substituting 3y equals x into the equation of the curve. And I'll continue it here. So instead of writing x squared for the first term, I'll write 3y all squared minus 2x y. I can write y as x over 3 plus, so we're rewriting x actually. Let's keep it all consistent. So x is 3y. So I'll substitute in 3y times y plus 3y squared equals 50. So now I want to clean up these terms. So 3y all squared, that's 9y squared, minus 2 times 3y times y, so we have 6y squared, plus 3y squared equals 50. So adding up these terms, 9y squared minus 6y squared plus 3y squared. So in total, we are going to have 6y squared equals 50. And so y squared equals 50 over 6. You can rewrite that as 25 over 3. And so y is actually going to be plus minus the square root of 25 over 3. That's going to be plus minus 5 over root 3. We don't like to leave surds in our denominator, so we will have to rewrite that as plus minus 5 root 3 over 3. So all I've done here is rationalize the denominator by multiplying the top and bottom of this fraction by root 3. That way, we get rid of the surd in the denominator, but then remember now we have the surd in the numerator instead. So my two y values are plus 5 root 3 over 3 and minus 5 root 3 over 3. And now to find x, so I'll just write it down here. Because we know that 3y equals x, we know that x, we can write it as x equals 3y. And so x will be 3 times plus minus 5 root 3 over 3. I'll write it all at once there. So we get both answers out immediately. And so x is equal to plus minus 5 root 3. So we have to decide which point is P. Well, it's in the negative x and the negative y. So point P will be minus 5 root 3 and minus 5 root 3 over 3. So those will be the coordinates of P. Okay.